So welcome to Security Automation for Enterprise IoT via intent-based networking. I fully realize that this is after lunch and most start making their stealth mode departures right about now. So I wanted to begin by at least thanking you for spending 30 minutes, taking 30 minutes out of your day to attend this session. Before we get into that, a little bit about myself. I'll just start with a quick introduction, let you know what you can expect for the next 30 minutes or so. My name's Anthony Sabella. I'm a principal architect for Cisco Systems, and I work for the Enterprise Chief Technology Office. We have a pretty neat team. It's a collection of subject matter experts in various different disciplines in data center technologies, WAN technologies, collaboration technologies. I lead the security efforts. And our primary initiative is to work together across architecture and try and create new platforms, solutions, strategies that will place Cisco ahead of the curve. I came here, it's a pleasant trip from the windy city of Chicago. Anyone ever been to Chicago before? Oh, we got maybe 5%, 10% of the audience. Awesome in the summertime. Great food, weather is just about like it is today, but wintertime, temperatures, -10, -15 Celsius, wind speeds like 40 kilometers per hour. So if you happen to try and purchase a surprise holiday trip for your significant other, and it's in Chicago in the wintertime, you'll probably be sleeping on that pull-out couch that they have in the hotel rooms. Winter, stay away. Summertime, awesome. So what can you expect for the next 30 minutes here? So if you like security and you like automation tactics, we got some pretty new technology to share, which I'm really excited to deliver today. We're going to start with the why before we get into the what. Some trends that are impacting the security landscape, along with we polled a large contingent of our enterprise customers and find out what their CXO level and find out what their concerns are, hence us creating a strategy to address that, which we're going to share today. We're going to introduce the concept of intent-based networking. Anyone ever hear of that before? Intent-based networking? Got about another 5-10%. So intent-based networking is going to introduce levels of automation in the service lifecycle, and we're going to take that intent-based networking concept, that's the underpinning concept to our strategy, and actually, frankly, most of the solutions that we had created in the past 2 years. So we're going to take that intent-based networking concept and combine it with cybersecurity to address use cases in a more efficient manner. So essentially providing the logic and the capabilities for administrators, such as many of you, to begin the self-managing, self-healing process. Administrators can start extricating themselves from normal day-to-day operations and start concentrating on more business-critical issues. So that's the premise. And then lastly, we apply this strategy on ourselves. We have a pretty large global infrastructure, about 75,000 employees. So we apply this strategy on ourselves, and I'll have some results which I can share so you can determine its effectiveness, okay? So since we have an action-packed half hour, at least I think it's action-packed, let's just jump into it. So again, the why before the what. So some trends that are impacting the security landscape. You see things on here like social engineering and crypto mining and network function virtualization, but there are two on here that are significantly impacting the way networks are designed, which is the influx of endpoints connecting from the Internet of Things and enterprise Internet of Things, and also the influx in how applications can be consumed. It was quite easy. It was private data center. Take your app, put it in your private data center, but now it's private data center, internet, SaaS, pub cloud, et cetera. So those two are significantly impacting how networks are designed, and how we choose to secure them is largely dependent on that underlying network design. So in working with our customers, we had seen a trend develop in how cloud adoption and cloud edge is taking place. On the left-hand side here is how we were architecting networks for the past 2 decades. Backhauled access, where you have a remote facility, campus branch, any type of remote facility on the bottom, traversing a private WAN to go to the data center, where your app was in a data center. That yellow circle is essentially representing where the security policy resides, or what we're calling the cloud edge, analogous to where the policy is. So you would take your app, put it in a private data center, build your policy or your DMZ there to guard the gold, if you will. And then we started adopting SaaS, pub cloud, et cetera, and we started building circuits from the private data centers, and we started doing it from all of our data centers. That's pretty expensive transport. And started backhauling internet over the private WAN. So in this use case, if you just take a look at this design model, which is largely the model that we've been using for the past decade or two, we have very expensive transport options. Two, it's inefficient traffic patterns, because if you want to consume an app in a SaaS-based app, internet, pub cloud, you got to traverse your data center. So inefficient traffic patterns. And then lastly, from a scalability perspective, it's not the most scalable, because if you want to consume new services, you got to keep running these new circuits. So fast forward to what we saw start coming around about 2 years ago with SD-WAN. We call this distributed access, where we're pushing security policy or the cloud edge, pushing it out toward the edges, at the remote facilities, at the branches, et cetera. So in this model, we have not a lot of customers, but we have a fair amount that don't want to own any private data centers. So they're coming to us saying, we want to get out of owning private data centers, we don't want to own any infrastructure. So they're going to take the majority of their apps, the ones that they can, leverage pub cloud at the top, AWS, Azure, GCP, whatever. And for the minority, let's start leveraging internet SaaS, but they're pushing policy out toward the edge, which we call distributed access. And then we saw something materialize about 18 months ago, which was really neat, in which, has anyone heard of, or is anyone familiar with, a carrier neutral facility or a colo? Okay, we have a large majority of people that are raising their hands there. So in a carrier neutral facility or colo, the service providers and cloud providers are co-located there. So your private WAN and internet are co-located there. Also, your SaaS and pub cloud, AWS, Azure, GCP, your SaaS, whether it's ServiceNow, Salesforce, WebEx, whatever, is also co-located there. So what we saw our customers doing, which was pretty neat, is right in the middle there, where that yellow circle is, they started securing a cage at the carrier neutral facilities and building a private cloud to front end all of their public access, and building their DMZ and creating a centralized cloud edge right there where everything already connects. And they're connecting their private data centers, partner connections into that. So we started leveraging our partnership with Equinix. Equinix is in over 200 data centers on 5 continents, so you can connect to service providers and cloud providers more bandwidth, less cost, oftentimes with SLAs. So those problems we had on the right of the expensive transport, those circuits now become cross connects right into the service provider's cages. The inefficient traffic patterns, everything becomes one hop away. If you're consuming private data center app, internet, IaaS, pub cloud, et cetera, all one hop away. And then lastly, from a scalability perspective, since all the service providers and cloud providers are co-located there, it's a simple cross connect, so you don't have to worry about provisioning. So when we see this new hybrid cloud design start taking place, the building blocks, you're going to hear me say these terms a lot. I just want to make sure that we're on the same page with these terms. Consumer is where the app or the user is. Provider is wherever the application is, regardless if it's private data center, internet SaaS, or pub cloud. And we're using that cloud edge, or customers are using this cloud edge to bring the consumer and provider together. So if we look at the two topologies for a moment, side by side, on the left side is that backhaul access, how we were designing networks for the past 2 decades, where you take your app, you put it in your private data center. If you look at the right, that data center is just another application provider off this application provider wheel that we're calling the cloud edge. So you're buying the flexibility of choice. You consume your app wherever you want and don't have to worry about inefficient traffic patterns or transport costs. So in polling about 500 of our customers, as these designs start evolving, we started asking our CIOs, our customer CIOs and CISOs, what are the top 3 challenges that you're seeing So we, Cisco, can start devising a strategy to address them. Number one was complexity. Nobody's just all Cisco or all one vendor. They're typically multi-vendor environments. But these multi-vendor environments, it was a pretty eye-opening stat, they're spending 3 times the amount on operating the network as they did to procure it in the first place. That's how expensive these multi-vendor networks are to operate. So complexity was one. 2 was inefficient. 80% of the changes were being done manually. Manual changes, they're slow, they're error prone. Errors lead to vulnerabilities. Vulnerabilities lead to breaches, right? And then lastly was with that influx of endpoint types from the IoT connecting and enterprise IoT connecting, along with the influx in application choices where you can consume an app instead of just private data center, internet, SaaS, pub cloud, that essentially led to an increased attack surface in which it's leading to increased time to detect and respond to these problems. So these were the 3 errors, or 3 challenges, I should say, in which we designed a strategy to specifically address these. Now this is, I just put this in there, it's just a quote that I like from Charles Darwin. It's not the strongest of the species that survives, nor the most intelligent, but the one most responsive to change. Now, intent-based networking is the underlying premise, underpinning concept to the strategy, and it's built on adaptive change. In quick summary, because we're going to walk through it in detail and then start applying this with cybersecurity, we're taking what you're trying to do, which is your intent, converting that into electronic rules and applying automation to it and instantiating all of your services on your infrastructure. And then leveraging telemetry on your infrastructure to see and have a baseline of what's happening so we can tie actionable responses to it, and we put it into a closed loop framework, okay? That's the summary of it, and we're going to start getting into more information. So when I say intent, if I ask 10 people what intent means, I'll probably get 30 different responses. I'm not even sure how that's mathematically possible, but I probably would. So for the context of today's presentation, let's just baseline what intent means here. So let's look at that top example, opening up a new branch to serve customers. On the right side, we got a workflow. Provision branch network, configure the wireless SSIDs, the secure access for the customers, the employees, the contractors, the vendors, configure the segmentation services, QoS classes, et cetera. That's just a small subset of the workflow. Now, 80% of this was being done manual. So you can kind of see the risk that you have. That's slow, it's error prone, leads to vulnerabilities. So what we're doing is we're changing that manual configuration to workflow-based automation tactics. So when we talked about intent-based networking, I said I'd get back to it. This is the slide, I'm going to explain it. This is the underlying premise to just about the majority of solutions Cisco is providing today. So we take what you're trying to do at the top, that policy, which was the intent we just talked about on the prior slide. We express that into an SDN control point at the top, which translates the what into the how and starts instantiating your services, deploying your fabric on your infrastructure. Now what we're doing is we're deploying, operating, and retiring workflows, people, places, things, apps. All of this was, or 80% of it, was being done manual. So now we're creating templates for you, putting them in the SDN control points, so you have to fill out the templates and it will do this for you. Now we're halfway around, we just instantiated the fabric, the services, et cetera, but how do we know our intent is being maintained? So we light up telemetry on the infrastructure, get a view into everything we're using. How is the network behaving? Once we have a view into it, we can start tying actionable responses to it, feed it back into the SDN control point. This is what we call intent-based networking loop logic. We're creating an intelligent closed loop framework, if you will. So to give you an example, has anyone heard of software-defined access before? We got a couple. So this is one of the solutions, just to provide an example to put this into real terms. Cisco created a solution called software-defined access based on this premise. Now the platform is what you see in the white. So we have the policy on the far right, an SDN control point, a policy engine, and an assurance platform. So we express our policy our intent into the SDN control point, which activates the fabric for us. Now, this is a single fabric for both wired and wireless policy, moving from manual configuration to templates. These are templates we placed in that SDN control point. You fill out, and it's now workflow-based automation to improve speed, improve accuracy, light up telemetry on this infrastructure, feed it back into the assurance platform, and now we can start tying actionable responses to it. Now, what do we use it for? Well, your traditional users, Windows, Mac, Linux, Android, iPhone, etc., the traditional users, as well as we're extending the fabric benefits. We call that the carpeted space, extending the fabric benefits to the non-carpeted space, so we can start providing these type of services to cameras, sensors, lights, etc., with no additional management overhead, because we've built the workflows into that SDN control point for the carpeted and non-carpeted spaces. Now, this is a security presentation, right? So you're probably thinking, well, where is the security? Well, the first part we're using it for is identity-based policy and segmentation. So we've decoupled the policy from location. Decoupled policy from VLAN, decoupled it from IP address, and what we're doing is as soon as an endpoint attempts to gain access, we're examining that endpoint, answering the who, what, when, where, how, posture, etc., and then granting a tag based on that input. So we take that information, we summarize it, associate a tag to it, and pass that tag ingress on however they're coming in, wired, wireless, remote access, etc. That tag represents three things: your identity, what you can access, and then third, serves as a form of micro-segmentation. So if you think about malware, now this isn't all malware, but the majority, when malware, let's say, happens to get past the initial line of defenses, it's on your machine, one of the first things it does is it runs a ping sweep on your network to see who's on my network. Okay, I found 15 hosts. Let me run a port scan against those 15 hosts to see what ports are open so I can start replicating, manifesting myself over to it, and then start finding privileged access so I can get data and export it for profit. So all of that horizontal movement is negated because of this is a form of micro-segmentation. Now this is built into the workflows, built into this fabric. Anyone ever hear of virtual route forwarding, or VRFs, a layer 3 form of segmentation? Okay, so we have layer 2 and layer 3 forms of segmentation. If you're familiar with the concept of zero trust, which we're going to get into in a moment, segmentation just can't be at the consumer side and at the provider side. You need segmentation all the way through your network. So this is providing both the layer 2 and layer 3 and mapping it for you. So as an example, we've identified the most common workflows, templatized them, put them in the SDN control point, and now one can start deploying their intent in a more efficient manner. Instead of, let me create my wired policy, now I'm going to create my wireless policy. Now, darn, I got to go create my security policy. All of that is baked into the workflows for a more efficient operation. What you see in red there, that's the security part of it in the templates. So that premise, intent-based networking, that loop logic, Cisco had built multiple solutions in the past 2 years on it. SD access, which we just talked about. We have an intent-based networking WAN, SD-WAN, an intent-based networking data center, ACI, and an intent-based networking cloud edge solution. We were talking in the beginning about cloud edge solutions. We built an intent-based networking cloud edge solution as well on that premise. And for SDN, are people in this audience, how many of you are familiar with SDN, software-defined networking? Okay, excellent. So what we're doing is we're taking security and building it into the SDN control points for each one of these architectures. So how do we start combining this with cybersecurity to address those three concerns that the CXOs had given us? We developed this 4-step strategy. We call them digital principles. The first one is integrated architecture. Second one is zero trust. The third is integrated assurance and threat detection. And the last one is dynamic security protection. Now we're just going to walk through each of these so you can see how this starts applying. So integrated architecture first. Cisco has got a very wide breadth portfolio with regards to security, so there's got to be some good way to organize it. So they just organize it according to categories: network, endpoint, and cloud. Pretty self-explanatory. But to drive the integration, that's a little bit more difficult because Cisco isn't just in security. They're in networking, they're in data center, they're in collaboration, et cetera. So on the left side, they first concentrated on, let's just integrate all of the security gear first. So let's take all of the security gear, drive integrations, and I'll show what those look like in a second, connect it to a common threat intelligence database, and then connect a single landing spot to get a purview of all of my security technologies, because that's important so you don't have to keep pivoting between technologies. The one in the middle is taking the security technologies and integrating them with the networking gear and the data center gear, implementing security into the SDN control points for each domains. And then the last one, we know that not everybody is all Cisco. So the intercompany integrations are as important, if not more important. The third-party ones are just as important. So Apple, Google, et cetera, we started driving integrations there. So I know this is an eye chart, but just to give you an example, because we're going to set this up for a later slide, dynamic security protection, the concept of self-healing and self-managing. If you take a look at all of these different products here, cloud gateway solutions, email gateway solutions, web security, firewalls, switches, routers, wireless controllers, et cetera, this is what Cisco has been doing over the past couple of years, is driving integration between these in these four categories: sharing threat intelligence, sharing visibility, event visibility, policy constructs, and sharing context. Now, the reason why we're showing this is going to serve as an underlying premise to the concept of self-managing and self-healing. You can't really do that unless your network is integrated. So how many here have heard of zero trust? How many here are implementing a form of zero trust? And okay, a fair amount. Great. So I like this picture here, so I thought I'd use it. The traditional approaches are falling short. That castle wall, when everything was inside of it that you needed to protect, and all of the attackers were outside, this worked pretty well. But I think we know that the lines of delineation between inside and outside are starting to blur a little bit, right? So there's been some evolution with regards to how this has been working and what the new perimeter security goals are. So provide secure access from any trusted user to any trusted device to any appropriate application. We got some words there that are italicized for a reason. So we came up with a framework. It's not our framework, but it's a framework that most of the industry was using. This 5-step framework. The most common parts, the parts that I just want to kind of focus your attention to, is confirming the user identity, confirming the device security separately, and then taking that, using and combining context with it to apply access to the appropriate applications based on these variables. So as an example, has anyone ever heard of a company called Duo? Okay, a fair amount, maybe a third of the audience. So we just recently went through an acquisition for Duo. And what Duo's concept is let's first examine the user. We're going to have an API into whatever identity database that you're going to be using. Let's say Active Directory, LDAP, et cetera. We want to confirm that this user should be on our network. They have an active account in Active Directory. Leverage multi-factor authentication capabilities, because even if you have credentials, those could be stolen. So how about some out-of-band multi-factor authentication capabilities? Now, in parallel, understanding the device security is as important, if not more important. So same type of access here. Querying a device inventory, whether it's an MDM, like Mobile Watch, Zenprise, or Jamf, or whatever you're using for your endpoint database, to first find out, is the device ours? Is this a company device? If it isn't, is this maybe something the person brought from home? Secondly, what is the security posture of the device? So using APIs and a safety net into Apple to say, does this device's security posture conflict with the policies that I have to gain access to these applications? Now they take these three variables, pump them to a cloud policy engine, which has got a single admin console for it. Now the cloud policy console is going to look at the user and the device and say, does this match for, let's say, to gain access to a private app, let's say Outlook? How about a public application like Dropbox or Salesforce? So you can have all three have got to be in concert. The user, the device, and then comparing that against what the application is expecting. So this allows us to start veering and eliminating borders. Now, most companies aren't borderless. They still have borders. So the traditional approach, the three main ways, if you have your networks that you administer, that one would gain access to a network, wired, connecting into a wall, or wireless, connecting to an SSID, or coming in from the remote access outside. We take those three and front end it with a policy engine, connection over radius. So we can answer the who, what, when, where, how for the device, and then based on that information, we create that tag, and then that tag, we share it. We share the tag with our own solutions, with third-party solutions, so they can use all of this information that we're collecting. The third step, integrated assurance and threat detection. So we're coming around the loop. Now we're going to start using the telemetry for the last part, tying actionable responses to it. So I don't know if, does anybody work in a security operations center here? So many have these questions, whether you work in a security operations center or not. Is this bad? Did it affect us? Where is this? How did this come in? What is the scope of the problem? Against the technologies that you see on the right-hand side. Now what we're doing is we're trying to aggregate and correlate all this information across all of these vectors, routers, switches, firewalls, IPS, web gateways, email gateways, so one doesn't have to pivot between all these consoles. Let's aggregate this information, pull it together. And here's a visual representation of essentially this concept. Is taking all these questions, pulling together all the event data and alert data from all of these different vectors, combining it with third-party intelligence feeds, our own intelligence feeds, threat intelligence feeds, and then presenting this to the customer visually. So to your SIM, if you're leveraging a SIM for more efficient forensic investigations, or teeing up the last point, which is dynamic security protection. We're doing all of this for a reason, right? Now this is the part that's constantly learning threat info and tying actionable responses to behavior. So as an example, what we're trying to do here is use all of this information to start automating your common workflows, your common scenarios. Network segmentation. So in the beginning, we talked about network segmentation from a NAC perspective. When you're trying to gain access to the network, let's look at the three gateways that one is coming in, wired, wireless, remote access, point them to a policy engine. I'll answer the who, what, when, where, how, and then I'll push you a tag based on your access. What if you're already on the network? What if you're on the network and now we want to determine, are you going to do something malicious? If you do something malicious, what are we going to do about it? So in this type of scenario, you're already on the network and malware happens to find its way in. Now, since the network is integrated, all of the components are integrated in sharing information, that fires an alert. Once the alert fires, we can start tying an actionable response to it. So we invoke a flow through that policy platform to quarantine the user. So this could be an internet-only access VLAN, it could be a port shut, it could be a port bounce. It just depends on your security policy. This can be automated, it could be manual, but the point is of trying to provide the logic and the capabilities to the user or to the admins to begin extricating yourselves from these day-to-day scenarios that take up a lot of time, allowing the network to self-manage, self-heal. Another common scenario, breach response. Just about every customer has got to deal with this. So if malware happens to find its way in, past the initial lines of defense, let's say, since the network is integrated, it's going to detect it, fire an alert. Once the alert is fired, now we can tie an actionable response to it. if you happen to have an agent on your machines, on your endpoints, we can remove that from all of the machines. But in larger customers, they've been a little bit hesitant to put an agent on all of their machines, and for good reason. I mean, if you have 20,000 endpoints, you may not want to do that. So instead, how about let the network take care of it for you? So since it's integrated, it's a see once, block everywhere type of approach. We saw this malware. We're going to send a signal to my network, my firewalls, my IPS boxes, my web gateways, my email gateways, that if you see this malware, if you see this file, if you see this hash, I want you to kill it so it doesn't traverse the network. So we applied this strategy, these 4 steps, introducing levels of automation and combining it with cybersecurity to Cisco across our network diameter, and again, 75,000 employees on a global scale. And the first 2 categories, if you remember the categories, complexity, inefficiency, time to detect and respond. Complexity, we took tens of thousands of ACLs and roped those down into group-based policy, a couple of handfuls of group-based policy, lended automation to them, and we've uncovered and resolved a fair amount of errors across the network diameter. For deployment, since we've taken manual configuration and created these workflows, workflow-based automation, put them in the SDN control points, that saved a ton of man hours for us because we've moved from that 80% of manual config to automation. And then lastly, since the network is integrated, we're leveraging telemetry and tying actionable responses to the telemetry so we can reduce our mean time to detect, mean time to repair. We reduce it tenfold using this strategy. Now I think I'm getting signals that I may be near the end of my time here, but if any of this information sounds interesting or you want more information on it, my email address is in the presentation. I'd be happy to answer any questions you may have. And with that, we can conclude.